Hi. Okay, so we have the SQL and database design today. For the first part of it, I'm just going to go over how to design a database and how to actually create them in SQL. So for now, you might not need any software, just a pen and paper for the first part, and then we have the actual software online for you ready, so you can actually practice. Thanks. Okay, so have you ever worked with Excel, Access, or Notepad? Definitely everyone did. They're all some sort of database. But if you worked with Access, they're the closest one to what we're going to talk about today. And Excel is trying, but not exactly. So let's just go over these ones. You all work with arrays. They're some sort of databases. Like data storage is a better word for it. Then we have 2D ones, because we need more information. Then we want to label this information. So we have tables, which is what Excel is doing. But after all of these ones, sometimes you need more. For example, you have a website that you want your users to have different access to different material, like posts. One of the tables is going to be users, and the other one is going to be posts. And then how are you going to actually have a relation between these? How are you going to say this one has access or this one is created by the post? That's where the databases come from. Oh, background remover removed a lot more than I thought. So this is an example of a database, but this is just the database schema. Why do we use databases? Why don't we just use Excel? Any ideas? Any hopes? Any? No? Okay. Yes?
Maybe it's not efficient.
Can you repeat it?
It's not efficient.
Yes, it is not efficient. And it's not efficient and it's not as useful, because imagine we design everything in Excel. We have one table for users, one table for posts, and then we say this post is for this user. Whenever we remove this user, what would happen to this record in the post? Because it's Excel, it doesn't know that that one got removed. So it doesn't have any relation. We're just saying numbers. That's why we have databases, and that's where the definition of relation comes in. So we have one-to-one relationships between tables. Can someone give me an example of one-to-one relationship? And why we might even use it? No? Yes? Can you say it louder a bit? A student and student information is a better example. Because so let me just show you one example here. Country and capital. Each country has one capital, and one capital is for only one country. So it can only be one-to-one. Each of them has exactly one thing to connect to. But then, what other type of relationship would you think of? Having one thing connected to several things, like the one that we had as user and post, which an example is mother and child. One mother can have several children, but one child can only have one mother, biological, if you say. And the way that these are actual notations for it. This one can be many. This one is the one. And then what other things can you think of? What other scenarios one might have in a database? You don't need to hands off. You can just say this is an interactive thing. Anyone? Okay, I'm going to go with this for myself again. It's a many-to-many relationship. But most databases right now won't allow this. Sorry, just give me one moment. It's muted. Many databases won't allow you to have many-to-many relationships. They only allow one-to-many and one-to-one. So we have to do a trick on them, which is adding an extra table to keep track of these two. But what might be the scenario that you need many-to-many relationships? Let's go with, what do we have here? Author and book. Yes, one book can have several authors, and each author can have several books. You can't have several, like, there are two ways to design this. You can have one book. You say, okay, each book can have max of 5 authors and have like 5 author IDs here, which makes this one-to-one, which makes it one-to-many. But that's very rigid. It's just very structured. You can't expand it. But in this one, you can, because you just have to add more author to book. I'm going to give you another example of how you would design a database. So let's go with the example of a website. Let's go with Instagram. You're making posts. What would be the relationship between your user and your post? Is it one-to-one, one-to-many, or many-to-many? Yes. Exactly. And then what would be, trying to think of many-to-many. What would be the relationship between comments and users? Is it going to be one-to-many or one-to-one? It's got to be one-to-many again. It's like one user can have several. And yes, you're right. We can't have many-to-one. That's technically another, just swap the order and make sense. So I want you guys to design a small database for two more. We have this sample IMDb database, which each movie has those fields, and we have a user that can interact with them, and then we have reviews for each user. And something to keep in account is the movie for cast, they can have several casts, so it's an array. We usually want to separate that into more tables. So, and the ratings are both over there and here are going to be float between 0 and 10. Since we're actually going to code this later, I would really appreciate it if you guys actually try to design a database for this data, so we can actually go over the steps of actually how to design it in SQL. So I'm going to give it like 5-10 minutes to design the database for this, and I'm here to help if you need it. And just as a thing, today the SQL that we are going to work with is MySQL. The general view is going to be all of the SQLs are going to be the same. They have small differences in some commands that I'm going to actually point out. So an example of a database is something like this. It's a way bigger than database that you are going to design, but I'm going to go over some of the relationships in there. Here, this is an e-ticket system. So they have tickets, they have users that can buy them, they have settings for the website, they have categories for the tickets they are selling, they have audits, they have ticket status, and I think there is priority. So what does it mean? We have all of this information. We want to show it in a way that is useful for a programmer to actually get queries and get those data as time goes by and as they need it. So imagine you are a user here, and you want to get a ticket. The ticket has some information about it, which is like, oh, that's very blurry here, which is subject, content, HTML, I don't know, the status and those stuff. You want to buy this ticket. So there should be a way to show that this ticket is yours. This information of these tickets are yours. As you can see here, there is a user ID, which is connected by this line to users. This we call a one-to-many relationship between the user and the ticket database. And what it means is one user, like for example I, and let's just say my ID is 1. With user ID 1, I can have several tickets. I can buy tickets to Taylor Swift concert, I can buy tickets to a movie, I can buy tickets to any theater or something. Each of those tickets are going to be one record in a database like this. And each record is technically one line in my table. It's exactly an Excel database, Excel sheet, but each row is going to be one record for this database or table. So, and then they have each ticket right now has a status. If it's approved, rejected, or pending. They could have had it as hard-coded, which means if the number is 1, it's approved. If it's 2, rejected. If it's 3, pending. But this is, you can't expand this. You can't expand this as you want. So they added a new table called ticket status, which has IDs for each of those statuses. So imagine in the status table, we have one approved, which has ID 1, one rejected ID 2, pending ID 3, and as much as we want, we can add more at any time. And then each of those IDs are going to connect to the status ID here, which means this ticket at any point can have one ID, can have one status, which is from another table. So if I have a ticket that is approved, for example, in this scenario, it's going to have the ID 1 as a status ID. So this ID is the connector between these two tables, which, as we go on in the actual SQL syntax, is going to be a primary key for ticket status, and here is going to be a foreign key connected to that one. So that's why I went over the relationships. In most cases that I see here, they're all one-to-many relationships, but sometimes you need more than just one-to-many. So yes, basically it's just how you want to show your data and how you want to visualize it in a database to make it accessible for any programmer. Yes?
Sorry, just backing up one step. When you say design a database, you're looking for a diagram like this?
Yes.
Okay.
I want a schema of a database, which this is what we call a schema. This is a website called Draw SQL, but you can do it in paper as well because you don't need this many stuff, so it's even more complicated to do with these devices. Like by pen and paper, it's easier because in this one you actually have to say your type of relation, and you have to actually specify if you have an ID or something. But this is something that you can think of. Why do we need an ID? And how many IDs we can have. Is it more clear that now that what we want? Okay. Oh yes. And if anyone is done, the website that we're going to use for all of the commands is create.utsc.utoronto.ca. I can actually write it down here. This is a platform that we just created for this and upcoming workshops. So even after the workshop, you can actually practice more with this. For now, it just has the SQL, but we're going to expand it a bit more. So let's just design it a bit together. If we have, I don't have the data anymore here, but you probably have it down there. So for the movie, what information do you want to have it in the movie table? Like, obviously, we want the title here. A bit more interaction. Anyone? I remember there was description there. Sorry for my bad handwriting. Rating. Any other ones that we need in the movie? Do we want it as cached? Because like, it was an array of information. We can't have arrays in databases. We want to separate that. Technically, we want each column to only represent one specific information. Yes?
Wait, in this case, sorry, I'm completely new to this, but could we do like a pointer to the array of the cast or something?
Can you repeat that again?
In that case, would it be possible to contain some sort of link pointer? I don't know if that's the term that applies here to the some array of the cast, or
Yes and no, somehow. So the way that we usually do this is we add a new table, which you're correct on this part, which is called cached. And this one is going to have all of those information, which is just name and blah, blah, blah. But how are we going to connect these two? It's a one-to-many relationship, which means each cast can have several movies. This way we can actually sort by cast. Because in the previous version, if we have one array of information in each movie, imagine Johnny Depp. We want to search for Johnny Depp in movies that he played. We have to go through all of the movies and see which one has Johnny Depp, or we can search in the cast and see which ones are connected to this. I'm going to give more examples. So cast and movie is it a one-to-many relationship or many-to-many relationship? If we have a cast and a movie table, only these two. Yes, many-to-many. And we said that we can't have many-to-many relationships in normal databases, so we need a middle table, which let's design it here. And let's call it cast movie table. What is it gonna have? This one is gonna connect cast to movie and be the middleman. So it's gonna have something from movie and something from cast. But how are we gonna identify each record in cast and movie uniquely? Because we need them to be unique here. We add a field called ID. That's the only reason that we have ID in all tables. The reason that we have ID is we might have, if we have user base, we might have several people with the same username and email, but we want to differentiate them. We don't usually want them to have the same username and email, but we still want some other thing to be the differentiation here, which is going to be their IDs. And IDs are always unique. I'm going to give you two different examples of implementations of IDs in databases, but for now, let's just assume ID is going to be unique. In this one, I'm going to have a cast ID and a movie ID. How are we going to create this? We have an array of information in each movie. How are we going to turn it into three tables? This is what I had to go through to create the sample database that we're going to work today with. each of those arrays can be all stored in one place, and then we can find the uniqueness. So we can just say how many different casts we have uniquely. Joined up is only going to be in that list once. Based on that, we create the cast table. We have the movie table, we have the cast table. We just go over all of those arrays for each movie and say, oh, Johnny Depp is in this array. I create one record in cast to movie for Johnny Depp ID and movie that he is doing. Pirates of Caribbean. I put these two IDs next to each other in a cast movie table. Does this make sense somehow? It's going to be a bit vague, but we're going to fix it over time. So this is mostly for the movie and cast part. What else? What other information do we have in the movie or user and reviews? Anyone? Yes?
In the movie, I assume it's going to be a very similar story with reviews.
For reviews. Do we want to put an ID for a review in the movie? Or do we want to put the ID of the movie in review? Because these are the parts that we're defining one-to-many relationships. We want to know which part is the one and which one is the many. And since we needed a many-to-many relationship, we needed a middleman, that is one-to-many relationship from movie to the cast movie, and then, and one from cast to movie, which technically this to this is going to be one-to-many, and this one to this one is still going to be one-to-many. But what about these two? Which one is going to be the one, which one is going to be the many? Can one movie have several reviews? Can one review have several movies? So what would be the sign? From where to where? So movie is the one. Okay, yes. And when one is the movie and many is the review, which ID do we put in which table? Do we put movie ID in review, or do we put review ID in movie?
Movie ID.
Yes. So this is okay for everyone? So the movie can have several reviews, right? So we can't store all of those review IDs in the movie, because we can only have one value for each column. We either have to add infinite amount of columns to our table for movie to store all of the reviews, or we can just simply put the movie ID in the reviews and tell, oh, this review is for this movie, and then we can search from there. So the whole reason is, in the databases, in each column we can have one type of value. It's not that we can have arrays. So we have to simplify everything. We have to make it searchable in a way that we don't have to search inside something, if that makes sense. So let's just do the same thing with user and review. Each review can have several users or can only have one user. Only one. So this is going to be a one-to-many relationship between user and review. But which one is going to have which one's ID? The review is going to have user ID. And now, if you look at it, the review is very similar to the cast movie, because they're technically both many-to-many relationships. But the cast movie has only the IDs because it doesn't have additional information, but the review needs more information, which is the comment and the rating. So this many-to-many relationship over there is carrying more information than this one, but they're both technically many-to-many relationship. Then we have, sorry, I have to add this here. And then we have a bunch of information for our user. So I'm going to actually show you the end schema for now. So this is what I was expecting technically to come out of this data. We have the show, which is the movie one. We have review. We have user. As you can see, this one has a one-to-many relationship. Is this better? Yeah. And then that one, that ID has another one-to-many relationship. This is the show of many. We have the same thing with these two. We want to connect the actor to show, which we need the show actor, in my example, cast movie. And then in between them, we have the many here. We have the many here, which is, I don't know, faded. And technically, the relation between show and actor right now is many-to-many because of these two parts. And then we had the show type. Over there, I said we can have, like, I didn't specify that we need a table for it. But why do you think I have a table for show type here? Show type means like one movie can be like movie, TV show, series, short movie, and those stuff. I don't technically need a show type, but why do you think I added it? In what situation having this extra table would help me? Yes? Yes, so I have a movie website and I want to see what type of movies I have. I can either go through all of the shows to find out which different types they have, or I can just look at this one, which is a very short list compared to the whole list of shows. So this is what we're going to implement today. Is everyone okay with the database design part for now? Because this is technically what the first step always looked like. From this point onwards, it's going to be syntax for SQL. And if you use different types of stuff like Django in Python, you don't even go through the SQL. You just have to design this. So this is always the starting point for most applications. And if you don't design it well, you're going to have problems that you have to go back and redesign everything. So I would suggest actually like paying attention to this specific part. But now, let's assume we want to create these. Before that, please go to this website and create an account for yourself. It's going to send you an email that you have to verify your email, and you have to use UofT email. That's where we're actually going to execute these SQL commands. And technically, you don't need a laptop for this. Anything that you can just type on the SQL commands would work. And if it doesn't look good, it was designed in 1 week, so keep that in mind. Create utsc.utoronto.ca. .utsc.utoronto.ca. It has a very simple user interface. The moment you log in, you're going to have one big box for execute commands. I'm going to give you an overview of what I'm going to go over today. After the, now that we finished the design part, I'm going to over creation of these tables with SQL commands. When I'm done with that, which I'm going to go in depth, I'm going to give you simple select and insert queries, which are adding data and just retrieving data. The more complicated select queries and insert queries and just delete and update are going to be on the second one, because we are not going to have enough time for it. So today is going to be more simple stuff, which is this database is designed for. For the next one, I'm actually going to bring the IMDb database in a weird design, so you have to actually go over more select queries. So is everyone registered already? Okay, so everyone okay? Should we continue? Okay, I don't see any objection. So I'm going to show you an example of a create table syntax, and then I'm going to go over each line and tell you what it is. Because personal experience, I don't think that telling you exact syntax just an hour each is going to help. More practice would help. So this is one create table syntax. It's big, it's scary, but readable. So it's mostly like actually like reading in English would tell you what it's going to do. So create table is like actually creating a table. The first name there is going to be your database name. I'm going to go over actually some of the conventions of creating database and column names, because this is a bad example of it. I'm going to go over them later. But the customers is going to be the name of the table. Then we have customer ID, which the first lines, other than the check, they're all just names of columns. They can be anything as long as they don't have a space between them. And some weird special characters. So stick to lowercase, underscore, these stuff. The first one is int, which is an int variable, and then auto increment. As it says, it's just going to go up automatically. If it starts with 1, the next one is going to be 2, 3, and so on. But the important thing here is primary key. Primary key means this field is going to be unique for all of the contents in this specific table. And this is the one that we can find records with. If we connect it to another table, this is what we put in the other table. We have several types of primary key. As long as you make sure that it's unique in the table, you can call it primary key. We can even have several columns being the primary key, but it's best practice to have only one. And then we have two major types that we have on databases currently. They are int auto increment, which is any record that you add, you don't have to worry about the ID. It just creates it itself by adding 1 to the last ID that it had. And if you even remove an ID, it's going to skip it. So it's always going to auto increment. And then there is another part, another way, which is called UUID, which is unified unique identifier, or unique unified identifier. I don't know the order of use. This is technically, it's getting more popular to use currently, because the way this works is this is going to be unique over any device, any table. Int in auto increment is going to be only unique in its own table. So if you have users and movies, they might have like same IDs. The first movie is going to have the exact same ID as the first user. But UUID makes sure that in all of the tables, all of the devices in the world, they're going to be different, which they usually do it with the MAC address. They have several different ways of calculating UUID. You can search online. But it's designed to be completely unique throughout databases, throughout tables, throughout devices. Yes? One of the reasons is sometimes you might want to merge two databases. If they have the same exact IDs, you're going to run into problems. If they have their unique IDs between them, it's going to be easy because they're just going to go underneath each other. But if they have the same ID, it's going to have problems because the primary key has always to be unique. And the reason is, for the different devices, is we want to make sure if you're generating it on your own, because it's not getting generated like int. The int is going to get generated on the server. But the UUID is usually generated on the device. We don't want to be, if you and another person are using the server at the same time, you're adding a new record. If your devices create the same number for the ID, it's going to be problematic. So this has to be unique between even devices. So yeah, keep in mind, primary key is always unique. Yes? It's for each record to have a unique identifier throughout anything. If it's generated on my device and your device, they're going to be different. But for the, yes? All primary key means it's going to be different in the table, but sometimes you need it to be unique over everything, even different databases. That's why you use UUID. Yes?
So if we use UUID, then can we just omit every single customer ID, name ID, or movie ID, and then just use ID in each of the tables?
Yes. So that's actually a convention that we usually have. In all of the tables, we don't have, if it's the customers table and we want to have a customer ID, we don't name it customer ID, we name it ID. And anywhere else that we want to use this, we name it customer ID. So that's a convention, but technically, all of these names are you choosing. So you can just, instead of customer ID, just say hello. And as long as you know what it means, it's OK. But for the simplicity of today, everything is int auto increment. So you can actually work around with it. And it was very hard to generate UUIDs for all of these sample data. Then we have first name, which is varchar. It means a variable as of character. The difference between this line and the phone is the variable character means the max it can be is 50 characters. The number in the parentheses means the max it can be. But the char10 means it has to have 10 characters. It's a bit more restricted. So you can't put information in a phone number with 9 digits or like 9 characters. It has to be 10. But in the first name, you can have Alex or Alexander. They both work and they don't need any extra things. Yes?
Why is it still checking if the length is 10?
Some of them are for your simplicity. So you know when you're adding a new record to your database, you know that it's safe to do so. If you add it without error, you know that it's a correct record. The other reason is the numbers has to be there. They are required. The reason is your database needs to know how much space it should save for that specific column. If it's 50, it only have space available for 50 characters. You can't put more in it. And it's usually best practice to know what is going to be the max length you want to put in. So you know that the username is not going to be more than 50 characters, so you put 50. Some may put 250, but no user is going to have like 250 character username. So you're just saving up a space, using up a space that you're not going to use, which is a bad practice. It makes your overall database very big. The not null, as English, it can't be null. If you try to insert a record that doesn't have first name and last name, it's going to give you an error. So these are more restrictions. You can, if you're doing in Python or something that is just connected to this, you can have all of these constraints over there, but it's better to have it here as well, because this is just double checking. Then we have the email, the same data type, but we have a new thing called unique. Unique is part of primary key as well. So in some databases, this is MySQL, but in some databases, they don't have the keyword primary key. You have to have unique and int or unique and like character. So actually, I forgot to say, this type of this is char 33 or 32. I'm not too sure. So in MySQL, you have the primary key a keyword, but in some of them you don't. So you use unique. Unique is universal. It's in all of the SQL syntaxes. And the way it works is if you try to add 2 email addresses with the same thing, because this one is an email address being unique, 2 person with the same email address, it's going to throw you an error for the second one. It's going to tell you can't add a unique. All of the emails has to be unique. Then you have the birth date, which is a date. We have several date columns. One of them is date, which in the database, it's going to look like, let me just remove this part. It's going to be year, 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 months, and then day. And then we have a date time, which adds time to this. And the time is going to be hour, minute, and then second. So we can have both of them. But here we only have date. Some people always add it as date time, but it's very annoying to add records to it because every time you have to set the time to be 000 or 11:59. So just choose whatever works for your application. I talked about the character one and then timestamp. Timestamp is very similar to date time, but it's usually used as default default current timestamp, which is every time that you add a record, it already has a value for it. So you don't have to give a value for registration date. It already adds the correct time, which the default keyword always means if I don't give you input for this specific column, use this, which current timestamp is right now. Technically, the time that you're inserting that record. Then we have enum, or enumeration, which is technically a drop-down. If you ever have a drop-down in your application that you want to be like active or deactive, this is the type that you use. It has active, deactive, and you can only choose these 2. Anything other than these, it's going to throw you an error. And it also has a default. You don't have to put default. So this part are optional. The not null ones are also optional. But if you don't give them, by default, they're considered null. They can be null. So this is how you can actually create a database. I'm not going to go over this one for now. So if you want to create a table, this is how you do it. All different types of data is mostly supported. And it's a good practice to check all of the data type names, the specific to your type of SQL that you want to use. The SQL server designed by Microsoft has a bit different syntax on int and varchar. And then the MySQL has a different one. And there are Oracle database that has a different one. So it's a good practice to check before you actually apply because some of them are going to throw you an error. And I'm going to go over check and connecting a relationship between the databases after the break. So have fun and enjoy. So everyone ready to continue, or do we want a bit more time? If no one has objection, I'm going to continue. No objection, okay. So I talked about all of the fields other than the check. So we talked about some constraints as of not null, character being 10 and only 10. This is another one. So in the check, you can actually add more functionality in terms of actually checking if this record is approved to be in the database. So in this one, technically, we don't need it because we already have the character 10 and it forces it to be 10 characters. But imagine this is customers. Yeah, this is customers table. So no birth date can be before 1700. If they are, they're already dead. They're not going to be our customers. So we add that check here. We say we say birth date has to be more equal than 1700. So the check just adds more restrictions. Some of these are not very useful in day-to-day application building, because you can have all of these checks before in your other program that is running these SQL commands. But it's good to have because it has double checking technically. Then I have the other example, which is orders. The reason I have this one is because I want to show you relationship and how we can add those. So if you don't look at the foreign key at the bottom, is this? Yeah. The first 4 are very normal stuff. The first one is going to be a primary key, which we talked about. The date, just a date. Amount, because it's an order. And then the last one is customer ID. This is the one that is connecting to the customer table. If we don't tell the SQL, it still works. We can have the customer ID put manually into records in orders. But if we do this, would it be any different than an Excel sheet? The reason that we have databases is that we want these relationships to be controlled by SQL itself. So an example is, imagine we have these orders, but then a user just decides to delete their account. If they do this, and we don't have all of these parts, we're going to have an order in the orders database that don't have any user associated with it. It's not going to be valid anymore. So at these points is that we tell SQL to keep the connection between these two, and even either give me an error if I try to remove one, or do some functions, which I'm going to go over right now. The syntax for adding the relationship is foreign key. In the foreign key, we say what column ID in here we want to use, and what does it reference to. So this one references to customers, table customers, and then customer ID. So the customer ID in the table customers. If we don't add these parts, like the onDelete and onUpdate, at all points, this makes sure that if you're adding an order, the order has a valid customer ID. I had that problem when creating the sample data. I was trying to add the movies and then users and then reviews, but I mistakenly added movies first and then reviews. The review was there. The moment that I was adding records to the reviews, it was telling me you don't have any IDs associated for this user, because I haven't added all of the users yet. So this one checks for those, and this is the part that actually creates a relationship. Then we have 2 small commands underneath, onDelete and onUpdate. OnDelete means what would happen if I remove my customer. If I remove that customer, what would happen to this record? And onUpdate means what would happen if I change the primary key of my customer? Do I change this one, or do I do something else? We have several functions for this one. I'm going to go over some of them, which are mostly useful, which are called cascade. Cascade means if the customer ID is removed, remove the order ID as well. So the moment that you remove a customer, all of their order records are going to be gone. Then we have onUpdate, which means imagine I'm a user in this system. I have the ID 1. And then I have several orders. The moment that I change my ID from 1 to 2, all of those orders are going to get their customer ID changed to 2. This is the most useful command, this is the most useful function that we have on onDelete and onUpdate. But we have several other ones, which are setNull, which puts that as null. Sometimes you need it. setDefault, which put a default value instead. And if I remember correctly, we have 2 other ones. One that alerts you, which is restrict. Restrict alerts you and doesn't let you delete the customer. And no action lets you remove the customer, but it's going to throw you an error saying you have orders with that user. So you're mostly not going to use any other ones than cascade and setNull and setDefault. So these are the main 3. But something to remember is I myself don't memorize all of these syntaxes. So I'm just going over them so you have an idea. But the way that you actually design your databases is the moment that you want to create the table, you just open W3 schools or any other ones that have the documentation for it. You just look up for the stuff that you want. So you want to create table, you just search for syntax create table there, because they might be different in different SQL servers. Ours is going to be MySQL, and these commands all work in MySQL. So like even when I wrote these, I actually went over them. And technically, in all projects, you only create the tables once. So you only interact with these once. So it's not very important to memorize all of them. Now I have those two codes next to each other, and the reason is this one is directly connected to this one. Here I'm going to go over some of the conventions for creating database names and database table names and record names. Column names is we usually don't go with plural, so customer, not customers, and order, not orders. And then in this one, we don't put customer ID, we put ID. Over there, not order ID, we put ID. But here, we still keep it as customer ID. Yes?
So just to clarify some syntax, so we have this foreign key basically telling us, okay, customer ID and order linked to this customer table.
Yes.
And then we have certain instructions as to what to do specifically if the customer ID gets updated or deleted or whatever. Is there any way to indicate that those on delete cascade and on update cascade belong to specifically the customer ID? Like if we had another ID in this table where we wanted to do something like different.
So the on delete and on update comes right after the foreign key. So if you have several, the one that, so you have another clause of foreign key with on delete and on update, they just associate with themselves.
Okay, so we just use order.
Yes. And make sure in all, technically the SQL commands are designed to be able to even run in one line. We usually put it in several lines to be able to see it better. Make sure if you do it in several lines, each line has a comma at the end. This comma needs to be there even in the one-line ones. And the last one does not have any commas. And make sure always to end it with semicolon. So these are all the stuff that we have for creating tables. Is everyone okay with them? Any questions? Yes.
Wait, what's the foreign key?
Can you say it louder a bit?
What's the foreign key doing?
So when we have this, it tells the SQL database that this table is connected to this table by customer ID. So the one-to-many relationship that we designed, this is the customer ID that we have in this one, which means this is a one-to-many relationship. And this is telling the database, keep an account, I can only have customer IDs in this database if they are present in this one. So it's telling the database, these are my relations. Before that, before I even work with these, you can still have none of these and still work with them, but it's like basically using sheets, using Excel sheets. I had them in several projects myself. It's sometimes annoying to have this because you have to always have the order right. You always have to add the record for this one and then this one. But as long as you can manage these, you don't technically need the foreign key. It's a better practice to have it. And in today's practice, please have it. It's useful. Any other questions? So remember that the database schema that we had for today? We're going to implement it in the platform that we have by these commands. So this is the table, this is the database. In the command lines that you have in the website, you can only send one command at a time. So one table at a time. And each command, what I mean by one command is from the start to the end, only one semicolon. And each table, create table command needs one semicolon. So you have to design the tables one by one. Something cool to something to test if your command line is working is to put this. Run show databases. you know what it is, databases. Another convention is most SQL databases right now understand if you put the command like show as lowercase. But the way it should be is all of the SQL commands are going to be all capital, and anything else is going to be lowercase. So that's why we have the create table and those stuff all in capital. MySQL understands both lowercase and uppercase, but some SQL databases are strict on SQL syntax has to be uppercase. One problem that you're going to run into when designing this database is show. We have the show table, but show also is a command. I'm going to let you guys figure it out how to do it. There's a neat trick to have commands as names as well. I'm going to talk about it later, but try to add it for now and see what happens. Try to have even a empty table called show and see if the system allows you to create it. Yes? So if you do run show databases, you're going to have 3 databases. One is with your username, and the other 2 are not accessible to you, but they are global. Then if at any point you created your tables and you wanted to see what tables you already have, the command is show tables. This shows the name of your tables. And then we have another command called describe, and give it your table name, and it gives you specifications for your table, so you can double check if you created everything correctly. I'm going to go over how you can actually change the databases tables that you create, but for now, you have a reset button. So make sure if you don't design your database correctly, you might have to reset the whole database. But there are commands that let you change your structure after you created the table as well. Okay, quick question on the design part. For the show type, can the type be null? Does it even make sense to have a type null when the whole table structure is for types? Nope. What about the references? If I have a user ID and I'm using it in review, can that be null? I have a review. Can the user ID in the review be null? No. And then if it's no, should I put it as not null, or should I just leave it alone? Considering we have the foreign key, the foreign key clause in the table, do I need to specify that this port, this column has to be not null? Why? Yes and no. So normally, if you don't specify not null, the column name, the information in that column can be null. But the moment you add the foreign key stops you. If you want to add a record with no reference to the other one, it's going to stop you and let you know, you already said this is connected to another database. I can't allow null or any other IDs that are not currently available in the customers. So in this one, I can't add any new orders for a non-existent user or for a null user. I have to know their user ID, and that user ID has to be already available in user table. Make sense? So it should help you a bit in doing the code. I'm actually going to show you my first code for this way. Yeah. So I'm doing the show type. It's an easy one. I have the ID, int, auto increment, primary key as we talked about, and then type being variable character or varchar, and then it has to be not null. Execute, command executed successfully, and let's see our tables. Hopefully I don't have any extra. So yes, we have the only show type. And now let's see how we designed it. Describe show type. It shows you that you have two fields, one being int, one being varchar, ID and type. They can't be null. One of them is primary key. They don't have default. And one of them has an extra command, auto increment. I'm pretty sure that in, I think SQL Server, we don't have the auto increment. We have a different keyboard for it. So again, it's useful to check the commands before you actually use any server. Now, since it might take a bit of time, how many of you have designed the show or any of the relational databases yet? OK. Nice. I'm going to give you another 5 minutes. Try to do those ones first, because they are technically harder to do and gives you better practice. But then I'm going to add a new feature to the app, so you can actually add information to it. Yes?
Sorry, maybe I just didn't check the design properly, but it looks like shows have directors. Should we make another table for those?
In this example that we have right now, each movie has one director, so we can just have their names there. It's not a list of information.
But for example, one like director to shows, that's a one-to-many, right? So
Yes.
should we have them?
It should technically be separate in a bigger scale application. But for now, in our database, it's just in the movie information. But the one that we are going to have for the second lesson, if everything goes as planned and I can finish the software till then, it's going to be a full IMDb database, which has everything. And if I show you the picture of the design, it's going to be, I think, nearly 10 tables. And you're not going to design it. On that one, you're just going to do queries and get information, which is considerably harder. Yes?
Would we want the actor name to be unique?
I can't hear you.
Actor name to be unique?
Actor name doesn't have to be unique, because like we can have several Johnny, and then one of them is Johnny Depp, one of them is, I don't know any other ones with Johnny.
The name, both names, or just the first name?
Let me just check. I think it's a full name in our database. But let me just double check. Oh, here it's full name. So we have one name column for the whole name.
Does that thing need to have a default?
Sorry?
If you want the default for that name,
I can't hear you.
it's default for that name.
So that's a field that can be null, because someone might be still alive. So you don't want to actually put a default for it. Yes? I'll be there in a sec. It might happen that you design your database and then you want to change it a bit. Usually when you have data in it, don't do that. It's a very bad thing to change your database or table after you have data in it. But if you want to do that right now, instead of the command create table, you have alter table. I don't have the exact syntax, you have to search it online, but it's alter table, table name, and what you want to be changed. And it changes it for you. Please look that up online before you do it. And if at any point, so right now, you don't need to create the tables anymore. I have them, like the moment you create on the reset and create sample database, it's going to create it for you. Hopefully you get the same exact green command. Did I write it wrong? Okay. So it should create all of these ones for you. And right now, they're all going to be empty, which technically our time is over. So I'm going to push all of the select and insert commands to the next session. But as of a preview, this is what we're going to work with next time. And you have all of the information there. So the platform is going to be open for everyone to use even after the workshop. You can just go practice around, create tables. This is all yours. Don't use it for production. It's only accessible through browser, so you shouldn't be able to use APIs. But don't add too many information there. The server might run out of RAM. And yep, you have access to the sample data if you want to go over select and insert commands yourself. Hopefully see you in the second half of this, which is on Friday, 5 to 7. Good luck and see you.